Hello, FTC Alberta. Welcome to April 12th, towards the end of week 3 of our FTC CAD Challenges. Today we're going to talk about a couple things here, but specifically we're going to look at how to build a bit of a file hierarchy in CAD just to make your life easier as you start to get more complex designs. We're also going to talk very quickly about exporting public links so people could actually look at your creation relatively easily, and we're also going to talk a little bit about motion links with uneven values, and that'll make a lot more sense towards the end here. So with that being said, what you're seeing on the screen is an example of a drive base, which was the assignment for this week, and I think we're probably going to leave week 3 up for another week here and not go on to number 4, because I think for most everybody, having 1 or 2 really solid pre-designed drive bases out there is actually a really good thing, because you never know what the challenge is going to be. What you're looking at right now is something that I put together in one of my classes. It's a modified West Coast drive style FTC robot. It's overkill in every sense of the word, but it's actually something that is fairly solid. However, for Skystone, based on where everything is on this robot, this isn't a particularly useful piece of machinery. What we're actually going to talk about to start with is we're going to put together a Tetrix kitbot, and I'm going to show you how I've put the file hierarchy together on this one. So what I've got here, if we go back over to my FTC CAD Challenges over here, we can actually see that I've got drivetrain and I've got a kitbot. Now, I've set up 4 files right now, and I'm just going to show you what's in them right now. We've actually gone ahead and put the Tetrix kitbot front wheel assembly, and this is all just if any of you have been following along and you just wanted to put together the basic Tetrix kitbot, the one that looks somewhat like this guy when all is said and done. This is all we're going to be building in CAD today. Nothing fancy. And basically this is the front wheel, and I've built it as an assembly because I know that this is going to be reused multiple times in my CAD file. In this case, it's going to be used on the left and the right side, and basically all this is going to do, because this part here, this particular assembly actually has 9 parts to it. We're basically making it so we don't have to reassemble those 9 parts all over again in our new assembly. Likewise, I know some people were looking at Mecanum drives, and those are ones where you might want to do those if you're having to manually assemble them as an assembly. The other piece is we've got our rear wheel here. It's relatively simple. We also have our frame, and I've built those as 3 discrete parts because when we're putting together this robot, it's going to be way easier to modify those pieces. And let's say I find out I want to modify the spacing on one of those wheels that's going to affect the other wheel. It'll do so automatically, and I'll show you what that looks like. We're going to go to another one. This is called Tetrix Kitbot Master, and I'm just going to show you what I've done. I'm actually going to go back to the start and leave this at a blank screen. I'm going to go grab my kitbot frame because it's going to be the base that everything's attached to. We drag it in. I'm going to leave it at 0, 0. I'm not going to mess with things, but what I am going to do is right click on it and ground it. That's going to make it so that it can't move around the screen. It makes it so I can attach things to it, and we can see how things are going to be animated. We went into that in week 2 quite heavily. I'm going to grab one of my front wheel assemblies and I'm going to drag it in here. Now, this wheel assembly has been built to go on the front of this robot here. And it's been built with one particular thing in mind, which is that if I zoom in and press this in here, I'm actually going to look at that wheel assembly and realize that the space between the 2 brass bushings has very specifically been set at 32 millimeters. And the 0.5 in there is because I accidentally grabbed one of the sides of the... I've grabbed the wrong side of the fillet there, and that's okay. What we're going to do with this is I'm very simply going to drop this guy in here as a joint, and I'm actually going to grab a spot to drop this in as a rotational joint, there and there. Now, you'll notice that because the order I clicked things in, it brought the bar from the frame down here. I don't necessarily want that, but I do want a revolute joint. When I press OK, you realize that I've now got this whole thing set up here. I believe I may have to make my frame a rigid group. Yes, I do. That's simply going to stick that frame together so that it's not moving separate from itself, and it should allow me to move my wheel. Sometimes you have to do that when you bring assemblies in. Now here's the fun part. If I drag another wheel in here, this allows me to bring those 9 parts we just talked about and really easily actually put those together for the other side. And again, this is going to allow us to put our joints in here less times than we would otherwise, because let's be honest here, if you're working with CAD, some of what you do in here can actually become really, really slow and tedious. I'm just going to snap back to my isometric view here and drop this into place. Now I'm still set to rotation. You can see the rotational joint right there. life is good. There's my other half of my front wheels. Now, before we go any further, I just want to talk about some things because I see this a lot with beginner FTC students. These two wheels are really good, but they have a bit of a problem to them. The biggest piece of that being that they're not very well supported. Yes, they're sitting on a U-channel, which itself is pretty rigid. It's pretty solid. But what they're actually doing here is they're sitting on the end of some really long lever arms. And this is something you're going to run into over and over again in robotics. The longer the lever arm, the greater the forces applied to it. It's similar to trying to, support a weight on the end of a hockey stick, if we're using that example. It's very hard to do the longer the stick is. But a shorter arm, like let's say you're holding something on the palm of your hand, your arm being a lever arm unto itself, is much easier to control. It's much stronger. Now, on the flip side, if you want to make something travel really, really fast, the end of the hockey stick's a really good place to go. We'll deal with that a little bit later when we start talking about flywheels in a few weeks. That being said, let's add the other wheels onto the back of this. Let's throw the back piece on here. And the key here is that you're seeing just how easy it is to reuse parts on this. And that's important because you will probably end up reusing parts on a large portion of what you do in robotics, one way or the other. So you may as well have some of these parts pre-built and ready to go. And this could apply to a drivetrain as well. I don't always recommend actually having your chassis pre-assembled before the build season starts. I'm just referencing the actual assembly guide here. I got to figure out which hole it has this particular motor bracket attaching to, and once we figured that out, we should have a mostly functional robot. It does indeed attach to this one right here, and I'm just going to change my change to a rigid joint here. I'm going to grab component number 2, and I'm going to attach it here. Now, since we're just testing the overall shape of things, we don't have to attach every single joint into place. That's not really important for us. But what we are doing is we're making sure that everything fits. We're actually floating around to make sure that we don't have any interference and make sure that we've got some good connections here. I'm simply going to copy Control-C and paste Control-V another version of this part in. And you'll notice in your browser, every time you do this, you simply get another set of components. Each of these could be opened up to all of the components that are inside, but it is linked to the actual piece over here that is showing where it came from. And again, I think we talked about that in a previous week, but this allows us to very easily, A, work with these pieces, but also B, to modify them if we have to in a very easy way. And I'm just going to show you a quick example of that. And if you've already seen it, I apologize, but it is one of the most powerful things about CAD that we use, period. Again, I'm just going to use a rigid joint, and I'm going to attach this piece to this piece here. Press OK. Now let's say that I was looking at this and I realized that I wanted these wheels to be a little bit closer to the frame. Okay, this is where this gets interesting because there are two wheels. Okay, I'm going to look here and I'm going to see that I've got a shift in Y of about 7 millimeters. So I'm just going to move this about 6 millimeters closer. What I'm going to do, I'm going to save my file first because why not? It's a good idea to do that frequently. I'm going to go back to my actual design here and I'm going to look at the actual rigid joint that attached this. Actually, this is going to be the rotational joint that attached this wheel to this axle. I'm going to right click on this and edit the joint. This is going to allow me to reposition the snap of the joint. In this case, I'm going to move it about 5 millimeters closer. In this case, it doesn't really matter where it is, but I just want to make it look a little bit, sneak it a little bit closer. Now, once I've changed that, I actually have a new version of this file here. So when I click save, what you're going to see is that my back wheel assembly actually goes from being version 2 to version 3, which is good. Again, I could reference that if I wanted to. But now I'm going to go back to my master here, which is the technical name for the kind of piece, the file where I'm bringing everything together. Now you'll notice that this still has that same gap in there, but that I've got a whole bunch of exclamation marks up here. This is going to allow me to actually go in and click my Get All Latest. It's going to go into my file system, it's going to grab all the part files I have, and it's actually going to move the parts into place based off of the new files. And you'll notice that that happened on both sides of this drawing. That's awesome. Now, the next piece is that I've got this good frame, and I'm going to call this a good frame right now because this isn't really a great frame yet. It has a couple of problems that you should try to avoid when you build your particular robot. The very first of which is those long lever arms onto the front wheels. That's not necessarily a problem if you have something running across the front of the robot to brace it off. Otherwise, these will tend to move a lot because they are unsupported levers. There's a couple ways to fix this, including sliding them closer to your frame. It reduces your place or your balance point on this robot, but there's nothing wrong with that necessarily. The other thing you're going to realize on this robot in particular, and I've seen a few teams use this particular chassis almost as is you have to consider where all the weight is on your robot. And right now we have a bit of a problem. The biggest problem being that the battery holder's back here, that the two DC motors are back here. All of the weight on this robot, all of the heavy parts are sitting right over top of those rear wheels. So this robot, when it drives forward, is going to tend to pull a wheelie. It's going to tend to have its wheels fly up in the air. And you kind of have to keep that in mind when you're designing, which is going to lead us to our next design in just a second. But we're going to show you a couple things right now on how to export this. So I've got this awesome drawing that's awesome, or this, it's really good. It's nice. CAD file, does its job. And what we're going to actually do from here is we are going to export it so people can see it. Now, all we have to do is go to this master file. It's the only one we need. We right click on it and we're going to actually go share public. Okay? Share public link is going to create a link to this particular file. Now if you keep changing this file, the link will continually update. It's in the cloud. That's why we use cloud-based things. And it's actually going to send a very simplified version of this robot off so that somebody can take a look. Now when I say somebody, I mean anybody. You could send it to all of the people doing these CAD challenges. You could send it to the rest of your design team. You could send it to your mentors. And anyone who's doing that can check it in any browser. They don't need a computer capable of running Fusion 360. They can also check it on devices. I have the Fusion 360 app on my phone. It works great. I just pull up the designs of people who want to send me something to show me how it works, and it is right there. We're going to share the latest version with anyone using the public link. If we don't do this, it'll take a snapshot of what this robot is right now, and it won't update it. It'll just take this moment in time. I want to actually include any version of this in here, and this takes a second. There's a little bit of a delay while it generates a URL. Okay, if you want to allow the item to be downloaded, you can. If you want other teams to use it, this is a kitbot. I have no problem with that. And if you want to require a password to access it, you can do that as well. Some teams that get really competitive at this actually want to have a certain amount of security around theirs. Me, I want everyone to see this one. I'm going to press copy, and I'm going to go over to our actual drive base. And this is the actual spreadsheet in the drive base challenge submission folder. So if we go to our folder, we go to challenge 3, we end up getting the drive base files link. Okay, and I'm just going to toss in my info here, and I'm going to I should probably throw a FRC at the front of this. All right, I'm going to throw the link in here. I have another link. We're going to talk about that link in just a moment. And then we're going to call this Tetrix Kitbot Chassis. Awesome. And this is a good way to share, because we can go in here, we can grab this link, and we can actually make something happen with it. But one last thing. And I promised one more thing that we talk about, and that is this tank drive. Now I just want to give you a quick tour of this robot. This robot would have been utterly useless for Skystone because it has a huge, huge top frame on it, but it has a few distinct advantages. Specifically that we could modify the gears on it if we wanted to. We can put different gear ratios on it. Emma! Yes, you may eat that. With those gear ratios being able to change, we have a few examples here, or a few things that we can do well. I've actually built this with chain in mind. Now you'll see that all the chain doesn't necessarily line up, but that we have built this so that it can drive all 6 wheels. Now there's a distinct advantage to this. If all 6 wheels are driving, and this is what we would call a modified West Coast drive, which is a really hard term to pin down as to what that is, but we have this really grippy wheel in the middle, which allows us to pivot around the center point of this robot. The front and back are omni wheels, which means they can drive forward, they can get you more grip, but at the same time they can slide as we're rotating to actually get out of the way if we have to. Now, one thing that I've done here is you'll notice that I've got rotational joints on all 6 wheels, but in the case of the left side of the robot, or right depending on how you're looking at it, I've actually got motion links in here. And you'll notice that if we zoom in on the gears, that these gears actually, and I just realized that my gears are actually slightly wrong on their motion link. I'm just going to go edit that there, and I'm actually going to reverse my gears. Now take a look at how this spins. We're going to show you how to set up one of these motion links so that they actually spin properly. Now when you do gear ratios, since I'm driving a larger gear, in this case I'm driving an 80-tooth gear, and I'm using it to drive a 40-tooth gear. That means for every 1 rotation of this 80-tooth gear, I'm actually going to get 2 rotations of the smaller gear. That's going to give me a speed advantage. And in the case of this is, it can be really powerful. It can make this robot go potentially quite fast. I've attached sprockets here to actually have chain link on them, and this is a really nice drivetrain because it has some redundancy. If one of these chains breaks or fails, you still have some wheels that are able to function. Now let's show you how to motion link the other side using that gear ratio. So if we go over here, we can see that we have motion joints. Actually, we have a couple motion joints here. I'm just going to spin my gear and see which one actually works. It's the one on the very end. Now when I move my gear down here, I spin it. I want to make sure I can see the motion joint. It's the one right here on the edge of the chassis. That's awesome. I'm going to go up to my motion link button. Yours is probably somewhere in your file folder. If you want to add it to your toolbar, you can do that as well. I use this quite often. So I'm actually going to click on the edge of this, and I'm going to click on this joint. And what you're going to see is it's going to start spinning the thing. Now, there's a couple things that are slightly wrong with this. Right now, I have these spinning. Oh, they are actually spinning in the right direction right now. Okay, but right now, for every 360 degrees the first gear turns, the other gear is turning 360 degrees. I actually don't want that. I actually want the opposite of that, because I want the other gear, the second gear, the driven gear in this case, to turn 360 degrees for every 180 degrees that the other gear turns. I am going to rotate this because I believe that's going to give me the motion I want. It is not. These are going to be backwards to one another. Just imagine your rotational joint, depending on which side you put it on, it could be forward or backward to the other one. As we spin this, we can see that we do get a motion linked turn here, and that is a good thing. What we can do then is we can actually take and just motion link things together. Now, when I motion link these things together, you can see that this doesn't look quite right, or this one does look quite right, because it is showing the 180 degrees of turn on the lower gear versus the 360 up here. That's going to build that motion link in. I'm just going to motion link the other side because I want to see this whole thing move. And you'll notice that since a lot of stuff is rigid jointed in here, oh, I must have grabbed on that one a piece that wasn't linked into the system the way it was supposed to. That's okay. Probably means I grabbed a bushing that I accidentally put a rotational joint on. There we go. Now we can see that we've got motion links on the whole system, so as I turn the drive gear, I can see just how this robot is going to function. Lots of motion links on this one, attaches to both sides. Both those chassis are in there, and again, once you've right-clicked and you've sent that link out, you can actually have people find the chassis. You can actually show what it looks like in a browser, which is something like this. Now, this robot has been built with that subsystem hierarchy in mind, and what that means is that these gearboxes here with the motors and these wheels with their axles are all separate files. What that means in this view here is that if I go to my explode mode, and this is a good way of finding out how somebody has built something, you can see that as I explode this design, and I'm going to zoom out a bit here, those subsystems, that full axle with the wheel on it, stays together longer until I get further into my explode. And that means that I can actually see how it has been built separate from the rest of the chassis, allowing me to reverse engineer this much, much more easily. Now, we've had a few other versions of this, and I just want to throw Nick's up on the screen here as well, because it shows up really nicely. If you want to change the textures on some of your parts, it will change some of the gray matte motor thing you have. It also depends on the quality of your step files. Nothing wrong with that. And I just want to say this is a really good example of a mecanum drive, directly driven off of the motors, and in a lot of years' games, this would actually be a very strong drive base. It also has a certain amount of rigidity because it does have support on the top and bottom, and it's, depending on how many screws you have in here, is probably actually going to work itself pretty well. With that being said, that's kind of an overview of a bunch of things on drivetrain. I think we might leave the drivetrain challenge up for another week here and just see what other drivetrains people can come up with, but as you find them, please toss them up in that folder so we can all share and we can make each other's lives a little bit easier as the FTC season goes ahead and actually make our season that much more successful. Cheers. Enjoy.